I feel that to some extent. All right. All right, y'all.
Good morning.
Good morning. All right. How is everybody doing? Slash. Does anybody have any questions? Good. For you doing all right. Ooh, look at that participant count. It's a climbing. All right. I'm just going to look at who's here real fast, and then it's time. Yesterday, technically, we learned that we can factor anything. And now, we're going to take that just one step further. Also, I just want to say again, heartfelt thank you to everyone that shows up to these. I know you're probably not all behind your computer the whole time, but at least you've made an effort to sign on. Well, Bam, or other Brandon, factor any quadratic. Let's not get ahead of ourselves. Factor any quadratic, which is huge for us as algebra people. Okay. All right, let's get this party started. Now, today, now I know you guys have some homework that might have some weird stuff on it, including things about the discriminant. Today, we could end up going over that today. But since it's not due Wednesday, we might not go over it till Monday, and that would be okay too for homework. Although I know you guys are itching to do your homework and get it done this weekend, right? Totally. All right, so we did completing the square. Pretty rad. Now we can factor stuff. But completing the square has a lot of legwork. So maybe we could come up with something that we could just plug into a formula of some sort. Well, let's find out. Let's say we had a generic quadratic equation. First off, is my voice coming through all right? Sometimes my microphone goes super wonky.
Yeah, it sounds good.
Okay. Sometimes I sound like a chipmunk, or so I'm told. Okay. Here we go. So here's A is a real number attached to x squared. B is a real number. we're pretending that A, B, and C are actually like numbers, where X is they're still variables. Pretend A, B, and C are some sort of numbers. But we're going to keep it generic. Now let's say we want to complete the square on this. Well, first thing we need is we need this to be a 1. So I'm going to divide all the way through by A. So what that gives us right here is just an x squared. That gives us here is plus AB over A x plus C over A equals 0 divided by A, which is 0. First step, this is actually a nice little review for completing the square. First step of completing the square, getting this to be specifically 1. Now, I'm going to throw the C over A over here. I'm going to subtract it from both sides. And I'm going to continue to do the process of completing the square. How did we do that, you might ask? Well, we looked at this term right here, remember? We cut it in half. So otherwise known as B over A times 1/2, which gave us B over 2A. Then what we did is we took this after we halved it and we squared it. Which gives us B squared over 4A squared, A squared. Okay, and that's what goes here. Now we're going to add this to both sides. B over 2A quantity squared. I'm going to add this here to this B squared over 4A squared. So far, so good. Just playing at this point. Okay. Now, this factors down into something very lovely. This factors down into, we've completed this square. This factors down into x plus something quantity squared, or plus this guy. Remember, after we have the middle term, that's what goes here. Now, I'm going to grab some like terms right here. This already has an A, so I need to multiply, little scratch work, I need to multiply negative CA by 4 over A, 4 over A. Giving me, so we have a positive B squared 4A squared minus C times 4A, so 4AC also over 4A squared. And just for clarity's sake. Oh yeah, if you're all writing this down furiously, you don't need to. It's just kind of just me playing around, and then it's the reveal. It's the bottom of this that you'll want to pay attention to. So what do we have here? We have x plus b over 2a quantity squared equals b squared minus 4ac all over 4a squared. This is where we're at right now. Now, just like with completing the square yesterday, we have something on one side that's squared, and then we still want to solve for x. That's been the point the whole time. And that's what we want to solve for. We want to get to x. So we're going to square root both sides from right here. So square rooting both sides. gets us to x plus b over 2a on this left-hand side, and equaling the square root of b squared minus 4ac all over 4a squared.
Professor,
Now, yeah.
Later on, are we gonna like have to remember how we got to the quadratic formula from here?
Absolutely not. No. This is me just letting you know how we got there.
Okay.
And this is it. If anybody's ever wondered how you got to the quadratic equation, bam, this is it. Take a generic one of these, you complete the square on it, snap. Okay. A little bit more scratch work. And it's already coming together, as you can probably see. So this becomes square root of b squared minus 4ac over the square root of 4a squared. This can't factor any further. But this is square root of 4a squared is just 2a. So that's what this becomes down here. So subtracting over our b over 2a, we have negative b over 2a. Oh yeah, we square rooted both sides, so this is plus and minus. Plus and minus the square root of b squared minus 4ac all over 2a. And last but not least, combining, now we have a common denominator. We have now here it is. Here it is. You're going to want to memorize this. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. And there she blows. We did it. We did it. We can factor any quadratic now. We just have to remember what our a, b's, and c's are. After that, we're good. We can factor.
That was completely hectic.
Wasn't it rad?
You were everywhere on that board.
It's actually pretty good. It's just like this, like this, like this. I've actually done a lot worse with board chaos.
I think it's because Joe left early yesterday. I don't think he saw that.
Oh, that's true.
I'm not sure.
That is true.
It's a lot better with actual numbers.
Yes, which we'll do a lot of. In fact,
Sounds good.
now for factoring, from here on out, feel free to use this. Honestly, sometimes this is a bigger pain to use than to actually just like factor it out quickly the way we've been doing. Because there's just a lot of stuff that can go wrong here, right? So you can like square a negative and forget to get rid of the negative. This negative 4ac right here gets really hectic when a and c are both negative, and then you're just like, I don't know what negative is anymore. Yeah, my dogs is okay. Now, also, some of you might be wondering, we've seen the word discriminant be used. The discriminant, let's check out, here's the radical, right? The discriminant is all of the stuff underneath it, under the radical. It's b squared minus 4ac. That is the discriminant. Notice, since this is under the radical, this little term right here lets us know what kind of solutions we're going to be looking at. What do I mean by that is this. If this just goes to 0 right here, then we're plussing and minusing 0. And so that means we're only really having that one solution, which is negative b over 2a. Likewise, if this is negative under this radical, now we know, we understand, we get complex numbers. We're going to get I out of this. And if it's positive, then we get like some real numbers. Okay. In fact, technically that is, yeah, actually, why not? I'm already talking about it. Let's make it official. So here's a discriminant, which is you always need to remember. So a lot of people want to say the discriminants is the whole square root term. Not true. Discriminant is just the thing under the radical. So I mean, this is the discriminant, specifically the discriminant is not, we're not talking about the actual radical part of it. Just the thing underneath. No, we're going to do a whole mess of examples after this.
Can you explain that again, but like, in, I guess, like simpler terms? I don't know.
With the, like, what kind of solutions you get?
Yeah.
Oh, yeah, totally. That's actually what the next section is about. And I'm going to focus heavily on that. So here's what you want to know with the discriminant. This will make more sense when you're using numbers. But for now, in general, let's say that this equals 0. So what you would get looking at the quadratic equation, we have negative b over 2a plus or minus blank over 2a. If this is 0, then you'd be taking the square root of 0, and you'd be plussing, minusing 0, and you would just get this, negative b over 2a. Which what that means is if b squared 4ac equals 0, then what you're going to get is you're going to get one solution. Technically, two solutions for the same root, for the same solution. But if b squared minus 4ac actually equals something and is greater than 0, then this is actually a thing down here. This actually becomes a number. This whole thing is greater than 0. And so tacking on to our negative b over 2a, we're plus and minusing some sort of number. And so if it's greater than 0, what we're going to have is we're going to have two solutions, or two x's. And they're actually different. Last but not least, if this whole thing under the radical is negative, then of course, if this whole thing is less than 0, then what we have is we have a negative under a radical. And so at some point, I will pop out. Because we have negative, like let's say 4 under the radical. So if this ended up being square root of negative 4, so something less than 0, this is going to equal 2i. So what that means, you're going to be adding and subtracting something that has an I in it. So you are going to get, if this is less than 0, you're going to get two complex solutions. And this is it. These are your only three options. Anytime you factor these things, one of three things is going to happen. You have a double root. So you'll get something like x plus 1 quantity squared. So -1, -1 is technically, you'll get two negative ones with the same number. So you end up just getting one solution. Otherwise, you can get two solutions, like -4 times x plus 4, or two complex solutions, where you have something like x minus 2i, x plus 2i. And that's it. Anytime you factor something, this is your options. One real solution, two real solutions, or two complex solutions. Oh, there'll definitely be a whole lot of numbers. But I know this is on your homework. This discriminant nonsense is on your homework, so I wanted to get through this. And now I'm just gonna put up a whole bunch of stuff. In fact, and I'll do some examples. Any questions so far? I know typically we get some questions when we actually do examples, but if anybody has any curiosities. Okay. All right, I'm gonna whip out I'm gonna do a quadratic equation guy, and then I'm gonna do a problem concerning the discriminant. Let's start off. I actually super love this one we're about to do. Actually, you know what? I'm gonna modify it. All right.
Did you ever figure out the tablet thing that you had?
Oh, still, no. Long story short now. Maybe one day, maybe not. Is the whiteboard getting a little passe?
No, it just looked like
Fun.
you get tired of having to still wipe
Oh.
the whiteboard every few minutes.
Oh, I don't mind. Okay, let's try to factor x squared plus x plus 1. I like this one a lot because it looks super simple. These all just have coefficients of 1, like, who cares? Oh, I see now why it's negative. Okay, screw it. Let's make this negative. Either way, same thing. 1 and 1 are factors here. So if we're going to factor this cleanly the way that we've done it before, this is 1 and 1, this has to be either a positive 2 or a negative 2. And we have neither of those. Next exam is your final, which is during finals week. And in your syllabus has the exam date. I actually think it's Wednesday this semester of exams week, finals week. Okay. So let's identify our things. Our A is a positive 1. Our B is a negative 1, and our C is a positive 1. Nothing too wild. So now let us plug it into the quadratic equation. Negative B, which is negative 1, this is where you need to be careful, plus and minus the square root of B squared, excuse me, minus 4 times A, which is 1, times C, which is 1. All over 2 times A.
Wait, how did you? Is this just from last problem? You're just using last problem, or?
This is me taking this guy.
Oh, so you already solved it out. You're just doing it now.
Basically, I'm going to factor this using the quadratic, or find solution, solve for x, find it using a quadratic equation. That's all. I'm just using the stuff, the formula that I derived. All right. So here's our thing. We're looking for x. We can't factor this easily, so we go here to the quadratic equation. So simplifying this becomes a positive 1. This is over 2. Sometimes, like, this is plus slash minus. Doesn't matter, make a difference. I can split this across the denominator, which I'm going to do right now. Now, negative 1 squared is 1. So what we have is 1 minus 4 times 1 times 1. We have 1/2 plus or minus the square root of, a negative 3. But remember, this negative 3 is the square root of negative 1 times the square root of 3, which is going to be I times the square root of 3. So what we have here is 1/2 plus and minus root 3 over 2I. If you have a long way to go in math, like differential equation, long way to go, this will come back up. All right. I know some of you have already used this, already know how this works. But for some of you that are new to this, here it is. Here's an example. Questions or comments?
Yeah. So basically, you just use last equation and use these numbers as an example, or what?
So this is what I wanted to solve for, and
Mm-hmm.
since I know it doesn't factor cleanly, I went ahead and used our trusty quadratic equation to solve for x.
Oh, okay.
Because what would be nice for this is if I could be like, x plus 1 times x plus 1 equals 0, and then I can tell you that x equals negative 1 and have it out. I'd be done with it. But this equals x squared plus 2x plus 1, and this is not that. And this does not factor cleanly into something like this, which is what we've been doing up to this point, which might add is still like a quicker, easier way to factor things, if possible. But if we can't figure out how to factor something, and we still need to solve for x in our quadratic equation set equal to 0, then we can always, 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 every time, use this guy. Making any sense?
Yeah.
Okay.
I think I was still on, like yesterday, thinking that we were gonna do that thing you showed us,
What thing?
like the square. Like
Where you're like square root both sides kind of deal?
No, yeah, like the completing the square, like I thought.
Oh, gotcha.
Yeah.
Unfortunately, in a way, completing the square is A, something you need to do. B, is a stepping stone to get to this, because this is the granddaddy. Okay. I will put some examples up after this, but let's go ahead and whip out. Yeah, I think this is exactly the kind of problem you'll have on the homework. And we're going to talk about discriminant stuff. Okay. So I believe, actually, I want to double check. Yeah, this is exactly what it's like. Okay. So on your homework, you're going to see something like this. I'm going to move to this side. Let's say you have a quadratic equation. 9x squared minus kx plus 25 equals 0. And let's say we don't know k, but we're going to find k. So that we get two complex solutions. So we have 9x squared minus kx plus 25 equals 0. And k can be a number of things, and we want to figure out which things it can be so that it gives us complex solutions for this. So like after we're done throwing these numbers into like the quadratic equation or factoring, we're going to get complex numbers. So what we do is the only thing we're worried about is the discriminant. So now in this case, looking at this problem, our A equals 9, our B equals negative k, that's the thing attached to the x, and our C equals 25. So now we look at the discriminant, which remember, the discriminant is the thing under the radical in the quadratic equation. So it's b squared, which in this case is negative k squared, minus 4 times 9 times 25. Now we want to get two complex solutions. So we want the discriminant that's under the radical to be negative, because we know when we take the square root of a negative number, we end up with I, meaning we're going to end up with a complex solution. So we want to know, now back to your favorite inequality stuff, we want this to be specifically strictly less than 0. And now we solve. So negative k squared is just that, it's k squared. Minus OI minus 4 times 25 is 100. 100 times 9 is just 900. Still just looking for k. Now from here, okay. Now from here, I'm going to add over a 900. Square root both sides, and we end up with the absolute value of k is less than 30. And of course, as we know from inequalities before, when I say the absolute value of k is less than 30, that means that k is sandwiched between negative 30, and 30. And that is all the values of k in this problem that would give us complex solutions when we solve for this quadratic equation. This is the general idea. Long story short, you need to know that discriminant equals b squared minus 4ac. This one's a little weirder, kind of a niche thing, to be honest. But you need to know it for your homework. That's all right, man. It'll take some getting used to, and I will talk about this like when when we start to wrap up class. Okay. However, in the meantime, how about some practice? How about some practice? All right, so basically this is going to be like use the quadratic equation. And I would advise you to actually use the quadratic equation and don't try to factor it on your own. For one, most of these aren't going to be easy to factor. For two, good practice. So using the quadratic equation, I want you to solve this. Ta-da!
If the
Yes.
a value is more than 1, do you want us to divide everything to make it less than 1 or to 1?
Nope, just throw that a into the quadratic equation.
Okay.
What's the second number on the second to last equation you just wrote?
This one?
The one right above it.
Oh, negative 12.
Okay.
Sorry, you said second to last. So x equals this. We've arrived, people. We have arrived.
You want us to do all 6 of these?
I mean, if you can. Just practice. Now that we've actually gone over some examples and done this, it's now you can actually feel and see how
Wait,
it works.
so I have a question. For the first one, do
Yeah.
I leave it in like the plus or minus form? Or do I? What's
So
the final form for these?
Like, what will be your answer, basically? Like, what's the form of the answer?
Yeah, exactly.
So for all of these, you're going to end up with x equals something and x equals something else. X is going to equal two different things, just like you've done with factoring other stuff. And those two things that you'll get will come out of here.
Can we leave it though in plus and minus, or do you actually want
Sure,
us
yeah,
to-
you can leave
okay.
it. You can leave it in plus and minus.
Okay.
That doesn't bother me. Just be sure to simplify like fractions and stuff. But besides that, you can leave it in the plus and minus form. Yep.
Actually, like after doing these, I remember doing this in like algebra 2.
Yeah, so this should be familiar, even though I introduced it differently and things like that. Yeah, this should
Yeah.
be something we've seen before. Probably.
It felt a lot different, but like now I'm like, oh shoot, I actually remember doing this a lot in algebra 2.
Yeah, this might have been something you learned pretty early on. I was saying the first part of that is off a little bit. That should be -5 divided by something. Yes. Whole thing is divided by 10, so that'll be divided by 10. Notice that for this one, I'll just talk about the discriminant thing for just a second. Notice that for this one we have our b squared, which is 25, minus 4 times 1 times 7. So that gives us 25 minus 28, which gives us -3 under the radical, meaning the discriminant is negative, which gives us, since this is going to be plus and minus √3i, this gives us two complex solutions. Our b squared minus 4ac is negative. But with something like 4, if you look at our b squared minus 4ac, we have -10 squared minus 4 times 3 times, well, after we bring this 8 over positive 8, which gives us 100 minus 4 times 3 is 12, 12 times 8 is 96. Now 100 minus 96 is positive. So under our discriminant is a positive, and we're going to end up with two real solutions.
Oh, that third one is in -3? Oh, that's the one under it. That's -3.
Yes.
Oh, okay. Shoot. Yeah, I wrote -3, but it's not.
But the fun thing with these is if you mess up a number, basically you're just going to be solving, you just gave yourself a new problem.
I still don't really understand what the discriminant is. Can you explain that again?
Sure. So basically, the discriminant is all we're worried about is you're looking at the quadratic equation.
Mm-hmm.
And the discriminant is everything under this radical. So the discriminant, like if it asks you for the discriminant, the discriminant is this, b squared minus 4ac.
Okay. And what does that like mean exactly?
Well, the reason we care at all about the discriminant is the discriminant by itself lets us know what kind of solutions we're going to get. So, like on this guy right here, x squared plus 5x plus 7, our discriminant, which is going to be under this radical, our discriminant is 5 squared minus 4 times 7 times 1. B squared 4c times a. This gives us 25 minus 28, which is a -3. So it's less than 0, it's a negative number. So when we go to actually solve the quadratic equation to get our x's, we're adding and subtracting the square root of -3. The square root of negative something is going to pop out an I, meaning that we're going to get a complex solution here, which is what this is.
Okay.
So
that's the answer for the first one, right?
Yes. So answer,
Yeah, that's what I got.
Cool. Answer for the first one, it also shows you that when the discriminant, when the thing under the radical is negative, you end up with two complex solutions.
Okay. That makes sense.
If under here is positive, then you're going to add and subtract something, a number, but you're going to add and subtract a number to this, to -b over 2a, which means you're going to get two real solutions. But if the discriminant is 0, then you're going to add and subtract 0 over 2a, which means this is you're adding and subtracting 0. So you only end up with the one solution, and that one solution is -b over 2a.
Got it.
Do you always want it written like that, or can we just put the whole thing over?
Written like what exactly?
Like you see how you have like -b over 2a plus 0 over 2a. Can we just leave it the whole thing under 2a, or?
Yes, totally.
Okay.
if you have complex numbers, you need to make this a complex number which has the separation, but otherwise, yeah, you can just leave it over 2a.
Okay, so for complex like that, you want both over like a fraction.
Correct. Just
Okay.
like this.
Okay.
All right, y'all. That is the class today. No, that was a bunch of stuff, but I wanted to give you guys the tools for working on the homework.
All right. Thank you. Have a good weekend.
Thank you, you too. Sure, what are your questions the same? I mean, if you have a mic too, feel free to use that. Yeah, sorry. If it's probably a pain to type, which you might be doing right now, but yeah, if your mic works, then go ahead and ask. But if it doesn't, then go ahead and type away. Oh, well, I would advise you to still go to the math lab because it's online. It's on Zoom, which is I mentioned in an announcement about a month ago. So I'd still do that. However, it's a unique situation. So I was going to, so for the extra credit, you were needing to go to the math lab 2 hours a week every week, starting from like week 3. So I have the numbers for if you signed in, how often you went from week 3. So basically, when campus was closed due to the pandemic, then I will just count, for now, I will just count from week 3 to when it closed, physically closed. And then I will also try to look at afterwards. No idea how that's going to work. It's probably not. But yeah, you just need to have gone up to that point. Yeah, we should have, if as long as you, well, here's the problem is, as long as you signed in when you went into the math lab, then I'd have your, how long you went and all your timestamps and stuff like that. And then with your PAL stuff, I don't know if anybody did PAL, but same idea, I think. Because they're still holding PAL sessions like they were, but just all online. It's just the same way the math lab is. Math lab's still online. All right. That was one question. Did you have another question, Hussein? I think it should be available, but even if it's not due till Saturday night. So tomorrow night, basically, as long as you're in a similar time zone. It should be. I thought I looked at it yesterday, and I think it opened up like last night or yesterday. I'll double check. I'm actually looking at it right now. 11.1. Yeah, 11.1 actually opened up in March 27th, and tomorrow night it's due. Well, Pacific Standard Time, it's due tomorrow night at midnight. Now 11.2 probably hasn't opened up. I will say that. That won't open till Sunday. That topic that's really odd. Well, it says work on your current objective. Does it tell you what the current objective is? Like, does it specifically state? Like, just curious, are you still in this time zone, or have you had to go home somewhere else? Well, if you've done, let me see. Actually, you might already be done. Who knows? Let me see. Current objective. Oh, which is says 12.1. So oh my god. There we go. Maybe this will help me. Okay, you're still at segment. Okay, I'm just wondering because of time. Somebody else had an issue with the homework being available because they're in a different time zone. Aha. Yeah, it's weird. So on my end, it's odd because it says you have one thing says you have 100% on it. One other one says you have 81%. It looks like you've been working on 12.1. Maybe not even working on it, but maybe you did something in the past where you were doing things like that. Yeah, your 11.2 is done. It's weird. To some extent, it says because 9.2, the catch-up objective, and 11.1 are all like in the same thing since I made them all do the same time. Part of it says you have 100% on it. I was actually going to look at the grade book. Oh yeah, I won't get that till it passes. I don't know. You should be good. Slash. That's so weird because it's still not due till tomorrow, so it should still be open. You should still be able to work on it. Well, here's the thing: is maybe after Saturday night, after it's due, it'll show me how much you did, quote unquote, like what the percentage is. And then if you still don't have like 100 or whatever on it, then I can just open it up again. It's just weird. It should let you work on it. It's still available. It should still be available. That's really odd to me. All right. Well,